Hello. So today we're going to read through an article together. You should have opened the PDF. I'm going to open it right now. It's called Forces Acting at a Distance. So if you look at the very end of the article, you want to scroll with me. These are the questions that we are going to think about and try to answer. What does it mean for a force to act at a distance? List 3 examples of forces that act at a distance. What factors affect the strength of gravitational force? And why do planets travel in elliptical orbits? So I'm going to go to the beginning of the article. It says, have you ever thrown a ball into the air and watched it come back down? No matter how high you throw it, the ball will always fall back to Earth. This is because of Earth's gravitational pull. You have probably heard of gravity, but do you know what it is? Why does gravity pull objects such as the ball toward the ground? Scientist in the spotlight, Sir Isaac Newton. In the mid-1600s, a young scholar named Isaac Newton developed some fundamental ideas in the history of science. According to legend, Newton had one of his most important ideas after watching an apple fall from a tree to the ground. This experience caused Newton to think about the different forces in the universe. Perhaps a certain force pulls objects towards Earth. By Newton's time, a scientist had begun to accept that the sun is the center of the solar system. That is called the heliocentric model. However, they still did not know which force held planets in orbit around the sun. Newton's answer was gravity. Newton's concept of gravity has been crucial to our understanding of the universe. Mass, can you say mass? Remember when we did that in class? The amount of matter in an object or a substance. Remember, mass measures matter. Gravity. Gravity is a force of attraction between two or more objects with mass. In other words, gravity is the force that pulls one object with mass towards another. The more mass an object has, the stronger the gravitational pull. All objects have a gravitational pull, but the gravitational pull of most objects is too weak for you to feel. Earth is massive enough that you can feel its gravitational pull. Earth's gravitational pull is what keeps you on the ground. So the larger an object is, the more gravity it has. So if we think about the Earth versus the moon is 1/6 the size of Earth. That means if you weighed 120 pounds here on Earth, if you went to the moon, it would feel like you weighed 120 divided by 6. That's right, you'd weigh 20 pounds. It's quite a difference, right? Sir Isaac Newton developed the law of universal gravitation. According to the law of universal gravitation, as the distance between objects with mass increases, the gravitational attraction between those objects decreases. In other words, the farther apart two objects move, the weaker their gravitational attraction becomes. Earth is very massive, so it has a strong gravitational pull. You'd have to move very far away from Earth to escape its gravitational pull. Now specifically, this is measured from the center of the Earth. So the higher up you get, you actually have less gravity. So if you went really, really far into the mountains, like really, really high up on a tall mountain, and you stepped on a scale, you would actually weigh a little bit less. Now, very, very tiny amount of difference, but there would be a difference there. What do you think? Gravity is a force that acts at a distance, meaning that two objects do not have to touch each other for them to exert a force. Can you think of other forces that act at a distance? You've already watched some videos this week. Yes, magnetic forces are an example of a force that acts at a distance. If an object has a magnetic field, other objects can be affected by that field, even if the two objects never physically touch. For example, when you place a magnet above a paperclip, the paperclip moves to the magnet even though the magnet never touched. And we played a little bit with magnets and electricity this year, and you know that feeling, that pull or that push that happens between magnets. Electrical forces are very same. They act at a distance. They are non-contact forces. When an object is electrically charged, it attracts or repels with other objects in electrical charge. Can you show me what attract means with your hands? Right? Pulling together. And repel is also a force. Repel with your hands would look like this, where it's pushing apart. When you rub a balloon on your hair, you create a positive charge on your hair. Oh, look, my dog is stopping in to see and say hello. Cindy, say hi to the kids. You create a positive charge on your hair and a negative charge on the balloon. And since these two charges are opposite, your hair is attracted. Remember when we played with the pieces of tape? And sometimes we would make the tape attract, and sometimes the pieces of tape would repel away from each other. People often use mass and weight as though these terms mean the same thing. Now, we talked about this already this year. However, mass and weight are different properties of objects. Mass is a measure of the amount of matter, the atoms. Your mass is the same no matter where you go. If you're here or you're on the moon, you're still made of the same atoms. Weight is a measure of the force of gravity on an object. Objects with more mass than Earth have stronger gravitational pulls, whereas objects with less mass than Earth have weaker gravitational pulls. This would make your weight different on other planets and moons. For example, if you weigh 100 pounds on Earth, you would only weigh 16.6 pounds on the moon. That's similar to the example I gave. However, you would weigh 236.4 pounds on Jupiter because Jupiter is so much larger. The moon is much less massive than the Earth, and Jupiter is more massive. Astronauts floating in space appear to weigh nothing. However, the astronaut's mass remains the same regardless of whether he or she is in space. The solar system. Gravity holds together the solar system. The sun is the most massive object in the solar system. Therefore, it has the strongest gravitational pull. The sun's gravity causes other objects in the solar system, including planets, comets, and asteroids, to orbit or move around the sun. An orbit is also the path an object follows as it revolves around a more massive object. The planet, comets, and asteroids all have their own gravitational pulls. They revolve around the sun because the sun is more massive. Remember, rotation means spin, and revolve means orbit, it means to circle around. Other objects in the solar system with orbital paths include moons and man-made satellites. Instead of revolving around the sun, these objects revolve around planets. For example, the moon revolves around Earth because it is much closer to Earth than it is the sun. Though the moon is less massive than Earth, its gravitational pull is strong enough to affect the planet. The moon's gravity pulls on Earth's oceans as it revolves around the planet. When the moon is closer to an ocean or a lake, it pulls the water away from the Earth. As the moon pulls away, the water falls back toward the Earth. We call these regular movements of water tides. You've learned that planets and other objects in the solar system revolve around the sun because the sun is so massive. Why do you think these objects don't crash into the sun? Elliptical orbits. As an object in space moves around the sun, it has a certain amount of forward momentum. The object's orbital path represents a balance between this momentum and the sun's gravitational pull. As long as this balance is maintained, the object will continue to orbit the sun. Now suppose the object collides with a large asteroid. The force of the collision could move the object closer to the sun. At a closer distance, the sun's gravity might be strong enough to overcome the object's forward momentum. If this were to happen, the objects would spiral toward and eventually collide with the sun. On the other hand, suppose the collision moved the object further from the sun. At a greater distance, the object's forward momentum might be strong enough to overcome the sun's gravitational pull. If this were to happen, the object would break free of its orbital path and move out of the solar system entirely. The orbital paths of an object in a solar system are not perfect circles. Instead, their orbital paths are elliptical or oval shaped, like an egg. This means these objects are sometimes closer to and sometimes further from the sun. When an object is closer to the sun, it is affected more by the sun's gravity. As a result, the object moves faster along its orbital path. When the object is further from the sun, it is less affected by the sun's gravity. As a result, the object moves more slowly along its orbital path. What I would like you to do now is to answer these questions. You can open a Word document and type your answers and submit it into the assignment, or you can handwrite it and send that in as a picture that you attach. There is also this assignment here where you're supposed to be filling in the different objects from space around these two different orbits. You do not have to do this question. You do not have to do the try now. You have to do these 4 questions right here. I hope you enjoyed this little lesson on forces, specifically gravitational pull. Bye.